Yeah there. Today we are going to solve another LeetCode problem named regular expression matching. Hard level, and it goes like this. Given an input string s and the pattern p, implement regular expression matching with support for dot and star, where dot matches any single character and star matches 0 or more of the preceding element. The matching should cover the entire input string, not partial. And well, there are some examples here, like for example the string AA and the pattern A. The result is false, it doesn't match. And well, when the string is AA and the pattern is A star, which means that any amount of A should be there, then the result is true. And so on and so forth. There are some constraints. The most important one, that it is guaranteed for each appearance of the character star there will be a previous valid character to match. Alright, so let's start to work on our code, and first thing which I would like to do is actually to convert our strings to the array of characters to avoid the usage of any API specific to the Swift strings. So how could we approach this? As you can understand, we need to iterate through all of the characters in the string and check if they match their place in the pattern. So it could be done with the cycle or with the recursion. And well, if we are talking some basics, like for example, if the pattern contains a regular character, then both solutions works. We could check that the character in the string is the same as the one in the pattern using the recursion, or we could check that if there is a dot, then we could just skip this iteration, because any kind of character could stand for the dot in the pattern. However, if we have something, some character which is followed by a star, then things become very problematic for a cycle. So, because in this case, the star describe not a single character in the string, but actually multiple characters. With the recursion, however, we could still proceed. Let's say that we have some string like triple A B, and we need to check if it matches the A star B. So how could we do that? Well, basically we should check that the first character follows that, and then execute this check of this pattern on the rest of the string. So here we're again going to check for the first character and proceed with checking of the rest of the string, and so on and so forth till we finally meet the case when we are going to check the B, which is going to return true straightforward, and then we would go back through the stack and return true for all of these cases. And also we could use the recursion for the regular cases, right? So for example, if we are checking that B follows A dot B, then first we would go and check that B, the first character follows this pattern. Then we will check that the rest of the string follows the rest of the pattern. Then we will check for the rest of the rest, and so on and so forth till we meet the B should match the B. So I think I was clear enough, and let's start implementing this method, which we are going to use in our recursion. So let's name it as isMatch, as well as the regular method, and it's going to have two arguments. The text, the array of characters, and the pattern, the array of characters as well. It's going to return the Boolean variable as a result, and we could just execute it in our main function with our arrays. So the text for a text and the pattern to be used for pattern argument. Okay, so let's start to implement this method, and the most obvious thing which we should do is to check for some edge cases. For example, we could check that the pattern is empty and proceed when it's not. Otherwise, the only case in which it would work for the isMatch function is when the text itself is empty, then the result is going to be true. All right, so now let's check for the star, because this is kind of a specific case which we should work with. So if our character is followed by the star, it means that first the pattern size is greater or equal than 2, and also that the second element in our pattern is equal to the star. And here we are going to handle this case. Otherwise, this is the very straightforward one. We should just check the first character and then check the rest of the text and the rest of the pattern. So let's create a variable, something like is first character match. And over here, first we are going to check that there is a first character, which means that the text is not empty. And also we should check that the first character matches the pattern. Basically, if the pattern first character is dot, then any character matches the pattern. Otherwise, if it's not, then we are going to check that the first character in the pattern matches the first character in the text. And as a result, we are going to return the logical n between is first character match and the result of the execution of the isMatch for the rest of the text and rest of the pattern. So how we are going to get these substrings? I suggest to use the suffix method. So over here we need just to provide the size of the suffix, as we are dropping only one element from the array. It's going to be the size -1, and well, we are going to just repeat it for the pattern over here. So we are dropping both the first character from the text and the first character from the pattern. All right, now let's get back to the star case. First of all, let's check that we could live without this part of the pattern. So what if we could just execute our rest of the pattern? For example, if we have the A star B and we have the string B, now we could check that, well, if it works for just pattern B, then it also works for the pattern A star B. So let's check that in this case. So we are going to check isMatch for exactly the same text, and for the pattern, which is going to be the pattern suffix with the pattern count -2, right? And so if it works out, then we are going to just return true straight away. Otherwise, we need to do something different. So basically, otherwise, if it failed, then at least the first character at this iteration should match the pattern. So we would need to use the isFirstCharacterMatch again. So let's just move this code a little bit to the top. And also let's modify it. So it's not going to be just a variable, but it's actually to be a closure, which is going to do the same, which means that it's going to just return the result of this expression. So if we don't have the star in our pattern on the second place, then we're going to just execute it straight away. Otherwise, we are going to check the isMatch for the pattern without two first characters first, and only then execute the isFirstCharacterMatch. All right, so if it passed, then we just need to check the match of this pattern for the rest of the string. So we are going to execute the isMatch for the text, which is going to be the text suffix for text count -1, basically for the rest of the text, and the pattern is going to stay the same. Okay, now let's check for any compilation issues. All right, some misspelling. Yeah, so it worked. Now let's submit this solution to check for the performance issues. I think they are going to be something. Yeah, so as you can see, we have the time limit exceeded for the case when we have a pattern with like crazy amount of stars. So as you can understand, the recursion goes crazy in this case. So how we could make this code better? So let's say that we are not going to do these conversions of the text, not going to allocate and reallocate the arrays, and instead we are going to provide the same text over and over, and we are going to just specify the different first index for the text. So we are going to start from the index number 0 and proceed with the recursion. So at this line, we are checking that text is empty. So if the text would stay the same and we just change the first index, it means that it could be replaced with text count is less or equal than our index. For example, if the count is 0 and the first index is 0, then, well, the result is true. The text, the part of the text which we are interested in is empty. Here we are checking the opposite thing. So we are going to replace it with text count is greater than our index. Over here we are checking for the first character in the text. So we could just use the text first index over here. Next we are executing the isMatch for the same text, which means that we could just provide the same index. In this case, we are actually modifying the text and we are removing one element from the start, first character, so we could just increase the first index and use the same text. And the same is over here. So we're just increasing the index by 1 and using the same text array. Let's check for any compilation issues on this code. Nothing over here. And let's check the improvements in the performance if there are any. Good. So as you can see, now we have 3 seconds. Still a lot, but at least we don't have an error. All right, so let's probably do the same for the pattern. Let's not modify the pattern and just use the first index of it. So over here we are checking that the pattern is not empty. We could just check that the pattern count is greater than the index. After that we are checking that the first character in our pattern is either equal to the first character in text or to the dot. Over here we are checking that we have enough elements in our pattern, so let's replace it that it's greater or equal than the first index plus 2, and if it's so, then we could address the pattern with the pattern first index plus 1. So this is how we are going to check for the star. In this execution of the method, we are dropping the first two characters from the pattern, so we could just modify the pattern first index by 2 and use the same pattern. Over here we are using the same pattern, so we are going to use the same pattern first index. And over here we are dropping the first character in the pattern, so we are going to just increase it by 1. Right? So let's check for compilation issues for this code. Something went wrong here. All right, the comma is not needed. And of course we do need to start from the first index. All right, now let's check for the improvements if there are any. Cool, so now it's 400 milliseconds. Really significant step. Okay, so now let's check what we could do even better. As you can understand, if we have a lot of stars in the pattern, then the code is going to check for a lot of different variations on how the code could match that. And it's going to execute the isMatch method a lot of time, and a lot of time it's going to use the same arguments. So let's create a cache and cache our results for some particular arguments. And for that, let's first create the keys for our cache. Let's name it indexes, or it's going to be a struct. You can name it indices depending on your level of geekiness. And it's going to contain the text first index, which is going to be integer, and it's going to contain the pattern first index, which is going to be integer. So now we would be able to store in some kind of dictionary, which is going to be the dictionary of booleans for the indexes keys. Initially it's going to be empty, and to make it work we also need to say that our keys are hashable. Okay, so now actually let's replace the arguments for our method. We are not going to use the pattern first index or text first index. We are going to just use indexes directly. So over here we are going to start with the initial structure. So the text first index is going to be 0, and the pattern first index is also going to be 0. As the first line in our method, we could now check for our result in our cache using our argument. And if it is there, we could just return it straight away. Otherwise, we are going to calculate the result first, and whenever we do the return from the method, we are going to put it to the cache. So let's create the defer. And in this block, when we are leaving the method, we are going to put the result to the cache. All right. So now we just need to instantiate the result. So over here we instantiate it from the text count comparison with the text first index, and we are going to return the result. Over here, instead of return, we're first going to put the result of expression to the result variable, and only then return the result. So now we have a lot of usage of indexes over here. We just need to replace them and use the structure instead, right? So text index, pattern index, text index again. Over here again, we're going to use the structure. When we are doing the recursion, now we are going to provide the new indexes inside this call. So we need to execute, construct the new indexes with exactly the same arguments over here, here, and in the last case. All right. And the last one. This and this. Okay. And finally, let's use the previous structure to construct a new one. Okay, so now our new method and new cache is ready. Let's check for any compilation issues. Cool. And finally, let's submit our solution. Nice. So as you can see, it was executed in 0 milliseconds, and it beats 100% of other submissions because of this. Basically, the execution time stands somewhere on the edge of the threshold. That's why it works like this. And that's it for today. I hope you enjoyed this. If you would like to see me solving other LeetCode problems, then put your requests to the comment sections. See you next time. Cheers!